Hey guys, good morning. We're going to go ahead and cover Lesson 10, Excluded Values in the Zero Product Property. We're really not going to emphasize the zero product property today in Lesson 10. We will emphasize that and teach it more in Unit 9 when we deal with polynomials. So right now I'll touch on the zero product property, but it's not going to be emphasized. Okay, so basically what we're going to start on is let's see here. All right, so we're going to start on page, what is this? 338. 338, okay, example number 5. So 338, example number 6. All right, so we're going to consider the equation 1 over x equals 3 all over x minus 2. What values of x would lead to division by 0? Why is division by 0 a problem? So if I have 1 over x, if I let x equals 0, I would get, for this first example, don't write this down, by the way, I'll tell you when to start writing, my apologies. So 1 over 0 if I let x be 0, okay? On the other side, if I let x equal 2 here, for example, 3, and if I plug in a 2 for x, and I go minus 2, that will give me 3 over 0, okay? So right now we're looking at zeros in the denominator. So if everybody got their calculator right now and they typed in 3 divided by 0, what does that give you? What does it tell you? Well, if you did actually try, it's going to give you an error. Okay? So what this means is that we cannot have a 0 in the denominator because it would be undefined or read an error. So with that, that didn't work out well. Let's go ahead and read the question and answer it together. What values of x would lead to division by 0? Why is division by 0 a problem? Well, if I had 1 over x, now you guys can write, equals 3 all over x minus 2, we would say that x cannot be 0 or 2, okay? And the reason we're doing this is to avoid a 0 in the denominator, but here's a bigger picture. You should be able to see that, oh, if I just put a 0 in there, that's not good. And then we're going to start looking at the idea of what's the opposite of a negative 2. The opposite of a negative 2 is a positive 2. So therefore, if x is a positive 2, these would cancel out and give me a 0 in the denominator. So what values of x would lead to division by 0? Why is division by 0 a problem? So division by 0 is undefined. Okay, I like to say, for example, 1 over 0. 0 is under the fraction. Sound like Nemo, right? No. So undefined, yeah. All right, so that's kind of the big picture for today. So let's go ahead and take a look at the next page. Example C, explain what Avery did in her first 2 steps and then finish finding the solution. Okay, so this is one way to do this, okay? I had taught you guys the cross product earlier, and I really do believe that that's the fastest way in order to solve, okay? I would definitely use the cross product, okay? But in this example, I'm going to show you guys one method to solve this. So what happened here is that, look at the denominator. You have a denominator of x and a denominator of x minus 2. The only time you're going to have excluded values is when you have variables in the denominator. Again, if you have a variable in the denominator, you're going to have excluded values. So, and here we have 2 different expressions in our denominator that contain variables. So there's one, it's just x, and then this is a different expression, x minus 2. So not only do we have variables in our denominators, we have different expressions, which means we're going to have two excluded values. So what we see here happening is that notice there's an x. Okay, so there's an x on this side. And then there's an x minus 2. And then on the x minus 2 side, there is an x and then a 3 all over x minus 2. Okay, so what's happening here is simple. Essentially what we're doing is we're going to multiply to clear the fraction of x minus 2, but whatever we do to one side, we have to do to the other. So here's the thing, the x on this side, so we need to, when you multiply, find a common denominator, I should say, for example, if I had 1 over 3 times 1 over 5, couldn't we just multiply the two together to find a common multiple? Okay, which is 15. And so we'd go 15 divided by 5 is 3, blah, blah, blah. So what we're going to do, instead of saying 15, we're going to show the 3 and the 5. That's the equivalent of what's happening here. We're going to multiply the two denominators together. So here are the two denominators. And then what we do to one side, we're going to do to the other. So the x's will cancel out, but we are also needing the x minus 2. So with that said, what ends up happening is the x minus 2's cancel out, and notice you're left with your 3x, okay? And then, but realistically what they're doing here in step 2 is, yes, these cancel out, and then you're left with the 3 times x, and over here, the x's cancel out, and you're left with the x minus 2 times 1. So step 1, we could just say multiply by denominators. Okay, step 2, we simplify. So we multiply through to get the 3x, so we're just going to say simplify. So we get, like we said, we had 3x, so there's your 3x, which would be here. And then 1 times anything is itself, so that's what we're left with. Okay, so I know that's kind of confusing, and that's kind of why I recommend us using the cross product on these ones. But again, when you have different denominators, and you're trying to eliminate and clear fractions, yeah, just multiply by the two denominators on both sides. Okay, and obviously the same denominators will cancel out, and then just multiply through the rest. So it's not very difficult once you get better at it, but I would definitely consider using the cross product. So I'm going to show the cross product one more time underneath. So it's 1 over x, whoops, sorry, it's ugly x, 1 over x, which equals 3 all over the quantity of x minus 2. Okay, but before we do that, we're going to go ahead and actually look at the excluded values. Excluded values are also known as restrictions, what x cannot equal, because otherwise it would lead to undefined. So in this example, we're going to say x cannot equal a 0, because if we put a 0 in for x, that's it, we're done. Or we're going to look, the opposite of a negative 2 is a positive 2. So x cannot equal 0 or 2. All right, so now we're going to go ahead and solve. I'm going to use the cross product. So 3 times x is 3x. And then I'm going to do the other cross product. 1 times this quantity. It doesn't matter what you put in front, it's commutative. So 1 times x minus 2. So we get 3x, and then 1 times anything is itself. Okay. So now we're going to go ahead and subtract x from each side to get 3x minus 1x is 2x, which equals negative 2. Now divide both sides by 2 to get x equals a negative 1. All right, so in this example, our solution is x equals negative 1. So that's okay. But the question says, are the excluded values solutions to this problem? The way we actually see, so are the excluded values solutions to this problem? So here are our excluded values. Is our solution a 0 or 2? It is not. So we cannot have an excluded value as a solution. So once you're done solving, you want to make sure that your solution is not an excluded value, because if it is, then there is no solution at that time. Okay? So let's go ahead and move on to the next one. Consider the following equation. Let's look at A. What values of x would lead to division by 0? All right, well, in this example, it's kind of nice because they're the same denominators, but there is a variable in the denominator, therefore we have to have an excluded value. So I like to just say, all right, well, if x has just got a coefficient of 1, okay, the coefficient of x is 1 on both, so we could just take the opposite, okay? So the opposite of a negative 2 would be a positive 2. So we're going to say that x cannot be 2, because otherwise, if it was, we would get 3. If we let x equal 2, it'd be 2 minus 2, which would be 3 all over 0. And we cannot have a 0 in the denominator. So that's the point of all of this, guys. We've already learned to solve all of these type of problems, except we're just introducing the excluded values concept. All right, so B says, clear the fractions to find the value of x. You can complete the problem in the box on the right. So here's the thing. Yes, I can use a cross product. Okay, I could. However, whenever your denominators are the same, the best bet is, yes, to clear the fraction and multiply it by itself. So in this case, I'm just going to multiply both sides by x minus 2. In the previous example, remember you had two different expressions, and that's why we had to get all crazy. In this case, it's pretty simple because we can clear the fractions. Anything divided by itself is 1. Again, anything divided by itself is 1. So we get 1 times 3, which is 3. And then we're going to set that equal to 5 times 1, which is 5. 3 equals 5. We lost our variables, didn't we? Well, when this happens, it's okay, because we would just say, you know what, 3 does not equal 5. That is not true. That is false. Therefore, there is no solution. Okay? Which makes sense because, like, if you have any fraction over the same number and the numerators are different, you're going to have different values, and it's not going to be equivalent expressions. So C says, how could you tell by looking at the original equation that the solution was going to be different? So the solution is different because it's no solution, and that's what makes it different. So basically, because the denominators were the same, numerators were different. Okay? All right, so that's the difference there. So let's see. When solving equations that have a variable in the denominator, it is critical that you exclude the values that would make the denominator equal to 0. So again, exclude, another word for exclude we use is restrict. So if you ever hear what are the restrictions, what are the excluded values, it's just what can x not be. So again, just to remind you guys, your numerator is on top. Numerator all over the denominator. So essentially, the denominator cannot equal 0. Okay? So that's where you can have, by the way, you can have a 0 in the numerator, because 0 divided by, let's just say 5, if you guys got your calculator, 0 divided by 5 is just 0, and that's an acceptable solution, which leads me to the next page, talking about acceptable solutions. So looking at page 340, we have It says, I've clearly I just wrote this out, so go ahead and ahead of time. So go ahead and take a second and pause the video and write this out. The acceptable solutions in this case would be one solution, exactly one solution, no solution, infinitely many solutions, or a zero. It's okay to have a zero as a solution. X can equal 0. That's okay. What X cannot be is undefined. So I'm going to highlight this in red as it is not acceptable. Any number divided by 0 is undefined, so that is not acceptable. That's the only unacceptable solution. So we avoid it by excluding the values that would lead to a 0 in the denominator. So with that, hopefully you guys went ahead and paused at this point just to make sure you had that at the top of your notes. So in the directions on this next part, it says determine the excluded values of x that lead to a denominator of 0 for each equation. Then solve the equation for x. So another note that I put is you can apply the zero product property whenever there's a variable in the denominator. Well, what's the zero product property? Basically, the zero product property states that that if a times b is 0, then either a is 0 or b is 0, or they're both 0. Again, anything times 0 is 0. So that's the reason why. So what they mean by that, and like I said, I don't want to gripe about it too much. When you use a zero, when would you use a zero property and why does it benefit you? Well, whenever you have a variable in the denominator, you can use a zero product property and set each denominator equal to 0. And in this case, x just cannot equal 0 because one of the numbers have to be 0 or they're both 0. In this case, x cannot equal 0 because there's only one denominator. In this case, I could use the zero product property and set it equal to 0. In essence, we're saying x cannot equal 0, but we'll talk about that later. Subtract 1, x equals a negative 1. So x cannot equal a negative 1, and setting the expression equal to 0 is using the zero product property. But for today, guys, we're going to go ahead and just use our common sense to find the excluded values, because I find that the zero product property is more confusing at this time than it is beneficial for most students. So we'll emphasize that again in Unit 9. All right, so obviously x cannot equal 0, because if it is, then you'd get 5 over 0, which is undefined. Now, the other thing is that I know right away that anything divided by itself is 1, okay? So anything divided by itself is 1. So I know x has to be 5. However, let's go ahead and solve. I can multiply both sides by the denominator because there's only one denominator. So I'm going to multiply it by that. So I get 5 all over x. And x equals 5. So that's my solution. Easy enough. We said that in the beginning. Anything divided by itself is 1. All right, now let's look at number 9. Number 9, we're going to multiply both sides by x minus 5. Sorry, let's find the excluded value first. Okay, so what is the inverse of a negative 5? Well, it's a positive 5. So x cannot equal 5 because if it was, 5 minus 5 would lead to a 0 in the denominator. So we just found the one excluded value. So again, if you have, looking at, all right, so we'll just go back, stay here. I thought there was another example I was looking for on this page, but there's not, so it's okay. All right, so with that said, let's go ahead and solve. Since there's only one denominator, guys, just multiply both sides by that denominator. So I'm going to clear the fraction by multiplying both sides by x minus 5. Anything divided by itself is 1, and then 3 times x is 3x. 3 times a negative 5 is a negative 15. And now we're going to go ahead and add 15 to both sides. and we get 16 equals 3x. And now we're going to divide both sides by 3. So we get x equals 16 all over 3. Now, just remember, get in the habit to make sure that your solution is not an excluded value. Okay, because if that happens, then there's no solution. All right. Now, let's look at number 10. Now, right away, isn't it true that I'm going to solve this both ways so that you could see it. But in this example, anything divided by itself, isn't that 1? So right away, I get 1 equals 4. Well, that's a false statement. So therefore, I know the answer is going to be no solution. So if you can recognize that right out the gates, more power to you. You can use that concept. However, I'm going to go ahead and solve this by clearing the fraction and multiplying by the denominator. Well, first off, I've got to find my excluded value. The opposite of a positive 1 is a negative 1. So x cannot equal negative 1. So I got my excluded value. Now, we're going to clear the fraction by multiplying both sides by x plus 1 because we want to clear the fraction. So anything divided by itself is 1, and we're left with x plus 1 equals 4 times x is 4x. 4 times 1 is a positive 4. Okay, so now we're going to go ahead and I'm just going to subtract, I'm going to subtract 4 from both sides to bring my constants to the left. And we're going to get we're going to get x minus 3 equals 4x. And then we're going to subtract x from each side. And we get my stylus keeps turning off on me. It's annoying. So we get negative 3 equals 3x. So I'm going to divide both. This thing is getting annoying. Divide both sides by 3. And now the 3's cancel out, and you're left with x equals a negative 3 divided by a positive 3 is a negative 1. So remember I told you guys to make sure that your solution is not an excluded value? Well, if you notice, our solution is an excluded value. When that happens, we sum it up to say no solution as our final answer. But like I said, we did all that work when if you know the rule, anything divided by itself is 1, you could have come up with the statement 1 equals 4 and then ruled out that there was going to be no solution. All right. So let's go ahead and take a look at number 11. Number 11, we're going to go ahead and use the cross product. Let's just start with the excluded values. My apologies. So right away, x just cannot equal 0 there. Can't have a 0 in the denominator. Now, we have another expression with a variable in the denominator, so we have to find out what would lead to a 0. Well, a negative 4 plus its opposite, a positive 4, would equal 0. So we're thinking opposites, inverses there, okay? So opposite of a negative 4 is a positive 4. All right, so now we have our excluded values. We have 2 of them, 2 different expressions, both with variables in the denominator. So at this time, I'm going to go ahead and I'm going to just solve these using the cross product because I do think that that's faster. Okay, so I'm going to go x times 3, 3x, and then I'm going to go, no, what am I doing? I'm going to put parentheses around the expression here and go 2 times the quantity of x minus 4. So I'm doing the cross product. Now you get 3x equals 2 times x is 2x. 2 times a negative 4 is a negative 8. All right, and now we're going to just subtract 2x from each side. And you're going to get x equals a negative 8. All right, So again, we just have to make sure that our solution is not a restricted value, in which case it's not. This is different than our excluded values, so we're good to go. All right, last two over here. So again, we have same denominators, different numerators. Remember what that led to. Okay, so first off, excluded value, the opposite of a positive 6 is a negative 6, okay? They're the same denominator, so we don't have to write it twice. Now, I'm going to multiply both sides by x plus 6 to clear the fraction. And then you're left with 3 over here. These cancel out to give you 1. And then we get a negative 6. So with that, 3 does not equal negative 6, and there is no solution. And we're going to remember, guys, whenever you have the same denominators but different numerators, even if it's a negative 6 equals 3, they're never going to be the same, so there's no solution. All right, last one. So remember, it's okay to get a 0 in the numerator, okay? Oops, sorry. In the numerator, just not in the denominator, because anything divided by 0 is 0. So this must be 3. 3 minus 3 would give us a 0. 0 divided by anything would lead to this 0. But let's go ahead and prove that. First off, we're going to find our excluded value. The opposite of a positive 2 is a negative 2. So x cannot equal a negative 2. Now we're going to go ahead and solve by clearing the fraction. Remember, there's only one denominator here, so that's the easy one. Whenever there's one denominator, you just multiply it by itself to clear the fraction. So anything divided by itself is 1. 1 times x minus 3 gives us x minus 3. 0 times anything is 0. And now we're going to add 3 to both sides to get x equals 3. Check to make sure that the solution is not an excluded value so that you can accept the solution, in which case they're different, so I can accept the solution. All right, guys. Today you guys are going to go ahead, the lesson summary, just read through that, please. Exclude any solutions that would make the denominator equal to 0. So example, in this one we only have one variable in the denominator, so x cannot equal 2. 2 minus 2 would lead to a 0. So the excluded value is 2. All right, so I went and your homework today is homework number 10, page 343, 2 through 5, and page 345, 15 through 20. And I gave you some homework help